The last class we discussed about functions, an interesting concept. We went through certain things like the definition of a function, some examples for a function, how to define a function, and what are its uses. So we have seen the syntax for a function. We have taken some samples on how to call a function. This is how you call a function. Give the function name and then two parentheses. So we have taken some exercises. We talked about four important parameters, right? We're able to understand those parameters. That is required arguments, default parameters or arguments. You can call them anything. So default arguments, keyword arguments, variable length arguments. We used a star, and we were passing variable length arguments, whereas these were non-keyword arguments. Whereas variable length non-keyword arguments were passed, to pass variable length non-keyword arguments, we use double star args. So we have seen all these things with certain examples. If you're not sure about these things, please refer to my previous lecture. And parameter types, we can check what type a particular parameter is before applying that in our expression. So we discussed about this instance. Is a particular variable of type integer, float, or string. You can check that before using that inside your function. We also discussed something on global and local variables, another very important concept. We'll revise local and global variables for some time, then we'll move on to other concepts. What all we are going to learn today is we are going to have revisit local and global variables for a short moment, and then we'll talk about return statement from function, how to return multiple values from function, passing lists, tuples, dictionaries to functions. Then we'll move to searching techniques, linear and binary search. We'll also write functions for linear and binary search. So we're also going to talk about searching techniques today. All these things we'll do today. We'll talk about local and global variables. What's a local variable and a global variable? So our first discussion is on local versus global variables. So you define a function, say I have a function add, and then a comma b are the parameters, and then I will print a plus b. So here, this is the function, and what are the local variables? What do you mean by local variable in a function? All the variables declared within a function are local variables. So when you talk about local variables here, say you consider this to be the function area. I'll put a comment here. So where this function starts, the function starts here. Just a simple explanation. Where this function ends here. Function ending area. So all those variables that fall within a function, so a, b, these are called what? These are called local variables. Local variables are variables within a function. So local variables here are a and b. Anything that falls within a function are called local variables. And you cannot access local variables outside the function. For instance, if I want to print a outside this function area, print a, immediately throw me an error. It will not be able to reach a because it's within the function. So you cannot access a local variable outside the function. So what's a local variable? Anything that's within a function is a local variable. You cannot access a outside the function. You cannot access b too. You cannot access anything that is local outside a function. Okay, so that's a local variable, and we have something called global variable. Now we'll see what is a global variable. Anything that is declared outside a function is a global variable. For instance, I can have variable c is equal to 10, d is equal to 15. C and d are global variables. I can access them within a function. Now I can go and access c and d within a function. Where is this function? This is the function. I can go and directly print c and d here. I can access a global variable within a function directly. So if you go and run this one, okay, I should call this function too, right? Because without calling a function won't work. So I can call and pass some values here. I can I'll remove the parameters. I'll not pass values. Now let me just go and call this function. So it's 10 and 15 is getting printed. The only thing is global variables can be accessed within a function. Anything that is declared outside a function is a global variable. Anything that is declared inside a function is a local variable. Local variables cannot be accessed outside a function. Global variables can be accessed anywhere. It can be accessed inside a function. So that's the thing. So now we have certain things that we have to learn here. So I'm using a global variable here. How all I can use a global variable within a function. So C is 10. I can print C. That is allowed. Say if I print C, you call the function, it will print C. But can I change C within this function? Can I change that? Say if I create C is equal to 12, what is happening here is I'll just show you. Initially global variable, this is a global variable C. So we'll have this to be global. So global variable is C, that is actually 10. Now inside the function I'm assigning C to be 12. I'm printing C. So this is like C within the function, right? Within function. I'll print the value of C. So what should be the value printed here? Within the function? 12 should be printed. So I'll also again print the value outside the function. I'll print C outside the function. Print outside function. Let's see what happens now. Within the function is 12, but outside it's still 10. So it makes a copy of C within the function, makes it as a local variable. C is equal to 12. It prints. Whereas outside the function, it's still 10. You're not able to change 10. So you want to change that global variable from within the function. You want to change this 10 to 12 from within the function. For that, what you have to do is you have to use this keyword global. So you say, I'm going to change the global variable C. You say global C first. Okay. And then you can change C is equal to 12 now. So I'm saying now, I'm not going to create a local variable. I'm going to change the global variable defined outside the function. Now when you go and run this code, you're going to get, okay, there's an indentation problem. I'll check what is that indentation issue. Okay. So when I run this code, you see here, both within the function and outside the function is 12 now, because I have changed the global value C to be 12 by acting it from within the function. So I just say global keyword C. So now it considers that to be the global value and it changes it. So local value variables and global variables are very important in programming, because in C, C++, any other language you're going to learn, you'll be working with functions, and every time you'll have this issue. Normally the practice is the use of global variables is not advisable in the industry. They will not allow you to use global variables. They will not allow you to declare global variables like this unless it is highly mandatory. You cannot do anything else other than using a global variable. Okay, so don't directly use global variables as you think. You have to use it only when it is mandatory. You don't have any other way of doing things. Otherwise, you have to pass that global variable to your function. You cannot directly access. You should always pass it. Say you call A and then you don't pass it, use it as a global variable. You always use it as a local variable inside the function. What is the local variable here? That is A. And you pass, how will you pass C to A? You just give add C. So you're passing this variable to a function. Don't directly use that variable inside your function. That's not advisable. So when you go and display this, see, it's 10, and within the function it's 10. Okay, so that's all about global and local variables. We'll learn about return statement from functions. What do you mean by returning value from functions? For that, let's take an example now. Returning values from functions. Again, it's also very important. Returning value from functions. So what do you mean by returning value? Let us take a name. Say I have my name here, and I want to find the length of this name. How will I find length of this name? len, and then I pass name, right? Now, what name does is it computes the, what length function does is it computes the length of my name and returns a number. It is giving back a number. So that is called returning. So I can assign that number that it returns to some other thing called length. So I am assigning a variable. Now whatever this function computes and returns will be in length. If I go and print length, 6. So this function is actually returning something back. It's not printing from within itself. It's giving back a value. That is called return from a function. So we'll see how to return values. We'll take our example. Do you remember this example? Computing length of a number. We did this in the last class. Computing length of a number. Do you remember that? How will you compute length of a number? You can have a function def num length, something like that, right? We defined a function and then we got this number from the user. And then we got this number from the user. You will enter some number. And then we have to find the length of this number. What we did, we said while number is greater than 0, we add this variable length is equal to length plus 1. When we use a variable, we have to initialize that, right? Length is equal to 0. And what we did, we also divided number every time by /10. And then we came out of the loop. We just printed the length here. Printed length as, we'll directly print length. That's it. And how you call this function? We have to just give the name of the function. This thing we have seen in the last class. Num length, length. This thing we have seen in the last class. When I run this and it asks the user to enter an input. If I say 1, 2, 3, 4, it'll say 1, 2, 3, 4. It gives length to be 4. So what is happening here is this function reads a number and it is printing length from within the function. It is not returning a value. I can't do something like this as I did for strings. I can't do k is equal to num length. I'm not getting a value to my k. So how to return this num length to my call is, instead of printing it here, what I'm going to do is, instead of printing it here, just use this keyword return length. So what's happening here, when I call this function, it starts from here, executes every single line, it computes the length, and then when you say return length, it gives back the length to my caller. So when this function is called, what I'm going to get back is some length. So how you get back the length? You have to return it. Return one value, that is length is getting returned from my function to where it is being called. Where it is called, here you are calling it. When I call it, what is that I'm going to get back? Length. The same way you have used for strings. You're getting length back, right? Now if I go and print length, it should work. So now let us run this program again. Indentation error. There's an indentation error that's popped out. Okay. Okay, here is this indentation error. Okay. So now let me enter, say here it's the same thing. I'm entering the number, but now it is returning the length back, and then I'm having length getting printed. So what is the keyword for returning a value? return. So that will return a value back to your caller. So if I want to pass the parameter, I can have a parameter to here, input name. Instead of reading the input here, what I'm going to do is I'm going to read the input from outside the function and pass it as input name. This also we did in the last class. So we read the number, and how will you pass the number? Like we pass for strings, it's num. Now it will find the length of this number, and then what it's going to do is it's going to return the length. Input num, and then you have input num, right? It's input name here. So we'll have its input num. So it's passing parameters. So what I'm trying to show you is an exact simulation of the length function that we are using for strings. Our function does the same work, except for, it finds it for the number. So how will I call this function? Num length, and I'll pass my number. What it returns? It returns a length. I print the length. So when I go and execute it once more, you see here, I pass this function 1, 2, 3, 4, 4. Yes, sir. So you understood the use of return? Return will return back a value to the caller who is calling that function. So now how many values I am returning here? I am returning only one value, that is length. So one value I am returning. So how many variables I have here? Just one variable to catch that one value getting returned. It's like I have a student here. I give him one number. He finds the length and he gives me back the length. So I am the caller of that student, right? I'm getting the length. I have to store it somewhere. So that is like, this length is like I'm getting the length and storing that in variable length. So he is the function, he is giving me the length back. So he uses return. Simply speaking, if I give him the number and he just speaks out loud, the length of the number is 4, then he is printing it out. Instead of printing, he just silently gives that length back to me. I'll use this basket called length, put that number inside that basket. I mean the length inside that basket. So that is this call. It's very similar, same to the way you use strings. You pass the string, you get length back, and then you are going to use that length in your programs. So this demonstration is like you can write your own functions, like what you have used for no, all those built-in functions you have used, right? You can write your own functions and use it. These are called user-defined functions. Okay, so the next thing that we are going to see is, can we return multiple values? Instead of only one value, can I return multiple values from a function? So for that, let us take a very simple example, how to return multiple values from a function. Let's start with, say, a very simple function will have no parameters we are going to pass. Say I'm going to return some values here. A is equal to 2 and B is equal to 3. I'm going to return A and B. So what I'm going to do is I'm going to just give return A comma B. And I'm going to return two values back. I'm going to say return A comma B. Since two values are getting returned, what I should have here is x comma y is equal to num length. I just call that function. So when I call this function, it will give me back A and B. I'll put A in x, B in y. So if I go and print x and y, what should be printed? It's 2 comma 3. See? So you can return multiple values from a function. You can also return a tuple from a function. How can you return a tuple from a function? You declare a tuple, A is equal to, how will you declare a tuple? 2 comma 3, and then you return A. So when I am returning this, I can also use a tuple here. I think this one also will work if I directly give it as 6 comma y. So I'm returning a tuple back and then I'm assigning it to x comma y. So if I print this one out, is it printing? 2 comma 3. A tuple is getting returned back. Likewise, I can return a list too. What is a list? You just put two square brackets here. Whenever you are going to get a list back, what you can do is you can create a list. The caller function, you can say it's an empty list, and then you can print L now. So what's going to be returned from your function is a list can be returned. So you can return a list too. So what is getting returned now? List. You can also return a dictionary. So what is a dictionary? It's a key value pair, right? Suppose I have a dictionary like 2 colon 3 and I want to return A. What I'm going to get here is a dictionary. So I print L. So it's going to be a dictionary. So within your function, you can use any data type. You can process values for the data type and return it like that to your caller. Okay. So it will be very useful when you're working with many different types of applications and problems. It's not only one value you will return, you'll return an entire data structure like that. Okay. The next thing that we are going to see is, can we really pass a dictionary, a list, a tuple to a function? What is that we have passed earlier? We have passed only one variable like an integer value we have passed. Can we pass a list to a function? We'll see that. So the next thing that we are going to look at is, can we really pass, what type of data we can pass? Can we pass a tuple to a function? Pass a tuple as a parameter. So what is that we are going to do here is, we are going to define test and I am going to say A is a tuple now. And we'll put this colon, we'll just say this print A. What I'm going to pass here is some C is equal to, I'm going to create a tuple 1 comma 2 comma 3, and then how to pass a tuple, just call the function name, pass C, that's it. Now C will be mapped to A will get that value in C. When I print A, what will be the output? 1, 2, 3. So you have received a tuple inside your function. You can process the tuple and you can also return a tuple back to your calling function. You can also pass a list. When you pass a list, what are the changes you have to do? Put two square brackets here, and then that becomes a list. Now you have received a list inside your function. So you can get a list of elements from the user. Just pass that list to the function. What you're going to do? Just give the name of the list. That's it. You can also pass a dictionary to your function. How can you pass a dictionary? What is a dictionary? Key value pair. So it's like 1 colon 2. It's a key value pair. And I pass a dictionary. Now I print the dictionary from within the function. So it's a dictionary. We have learned very crucial things like we can pass dictionaries, tuples, integers, floats, strings, sets. We can pass anything. We can also return multiple values from a function. We can return a single value from a function. The only thing is, while you are getting such a value, you should make sure that you are getting it as in a dictionary or in a tuple. You have to ensure that you put that in the right variable for processing. Is this clear? Am I very faster? The concepts are simple, right? But these are very effective and very powerful concepts, I'll tell you. Many times we'll be passing a lot of data between functions. When you think of any system like VTOP or any big system, railway reservation, airline reservation, you think of any system, it's like thousands of functions talking to each other by passing values between them. That's it. So it's all function oriented and object oriented too. We have a lot of functions inside the classes. So how methods communicate is again a part of function communication. So now let us go to our next concept. So we have seen all these things, returning multiple values from functions, passing list, tuples, dictionary to functions. So all these things we have done. Now we'll go to interesting things, searching techniques. Two kinds of searching we learn, linear and binary searching using lists. Okay. So we'll start searching techniques, our next topic for today's class. Very simple and easy, but extensively used in computer science. So we'll see what are searching techniques. The name itself says it's used for searching something. So if I want to search for a student in this class using his registration number, say you are all seated according to some registration numbers. If I want to search for one particular registration number, say I want to search for some registration number, I don't know which one to take. If I'm going to search for some registration number, say 18BC0, I write something 125, something like that. So how will I start searching? I'll start searching from here. I'll go every student. Are you 125? Are you 125? I'll compare your. I'll take your ID card. Check whether you are 125. If you are 125, my search stops here. If it's not 125, I'll go in that order. Go to every student until I reach. So I'm going in a linear order. So that's called linear searching. So from the start to the end, I have a set of numbers. I start searching it in the linear order. When I get my element, I'll stop. I'll say element is found. Till the end, I'm not getting the element. I'll say element is not found. So that is linear searching. So the first thing we are going to search is, we are going to talk about this basic technique, linear searching. Linear searching is a very basic and simple search algorithm. We search an element or value in a given array by traversing the array from the starting. Instead of array, you can say it's a list. So I'll give an example here. Suppose you have this list. What all elements you have here? 7, 5, 4, 6, 1, 2, 3. It's not in the sorted order. You have a set of elements. That's it. And what I'm going to do, search an element from the list. If I want to search for 2 in this list, if I want to search whether element 2 is there, how will I search? I'll start with 7. Every time I'll compare, this is 2. No. Is 5 2? No. Is 4 equal to 2? No. 6 equal to 2? No. Like that until I reach 2. When I reach 2, 2 is equal to 2, then I will stop my search. I will not go and compare whether 3 is equal to 2. Because it's not needed. So one element, I know if it's found, then I will say element is found. It's a very simple search algorithm. So, Okay. So now, can you write code for this using lists? So you have to get a search element from the user, and then you have to compare that with every element in the list. If the element is found, say element found. If you don't find the element till the end, you say element not found. It should be a very simple algorithm, right? Can you implement this? Can we write the code? Then we are done with our linear searching. So how can you do linear search? Let's try simple algorithm. You try it on your own. So I have some list here. L is equal to, I'll take that list 7546123. So let's have 7546123. And I should get a search element from the user, right? You'll say int input, enter your search element, enter search element. The next thing that we are going to see here is we have to traverse that list. How will you take every element in the list for I in L? So I will take every element in the list. If search double equals I can say found is equal to true. I love this variable here. This is like a flag. Okay, every time if I find something, I'll put found is equal to false. And then I can break this one too. So these are like unique thing. So if I find an element, I'll break it. If I find my element, I'll break my search and I'll come out. So here, what I'm going to check is if found is true, then I'm going to say print element is found. Else, you're going to say print element not found. Very simple code. So I'm using this flag. Initially, found is false. I have not found my element. So I'm traversing the list for I in every element in the list. If the input search element is equal to the element in the list, then found is equal to true. I set found to be true. I break my loop and come out. If this condition is not set to true, then it means that the element was not found in the list. So I just go and write if found, print element is found, else print element is not found. See, some students, what normally their mistake they do is they will always write if this is, then they'll say print element not found. If you do this, what will be the error? Every time it will say element not found, element not found. Say if I'm going to search for 2, it will search for 2, compare 2 with 7. So it will come to the else block and say element not found. But element is there at a certain location. After certain number of searches, it's there. So this is one common mistake I've seen. For many years, I've been seeing this mistake. So that's why we have to use this found is equal to true, this flag. So once when it finds a match, it will set that flag to true. If it is not setting that flag to true, there is no such element in your file. So let me check whether my code really works. So let me go and check it. Enter search element. I want to search for 4. Element is found. Suppose I want to search for some 55. Element not found. So we have finished linear searching. You all have completed this code, right? But can we use this algorithm for all our searching? Where all we use searching in our systems? Say I know we all have voter ID systems, Aadhaar ID systems, and suppose I want to find a person's detail using his Aadhaar ID. So how many people, we have, say we have 100 million records we have to search. So 100, when you start searching linearly, maybe you're searching for the last person. So you have to traverse through 100 million records. So it's going to take a long time. You're going to wait for that search to happen. Many hours can take. So that's the disadvantage with linear search. When you're using a large input record, input data size, it's going to take a lot of time depending on the data size. So we'll take a look at this, some of the best case scenarios here. When we have to analyze the complexity of the algorithm before using it. You can't just like that use an algorithm in our solutions. So when you analyze the complexity, when linear search will be very effective, when the search element occurs in the beginning. When the search element is at the start, always your search time is going to be constant, right? For any input list of elements, I can have 100 elements. If my search element is always in the start, my search time will always be constant. So that is the best case. The best case is your search element should be at the beginning. Then for any input data size, your search time will be constant. Your runtime will be constant. Whereas, what is the worst case? If I'm going to search for 3 here, 3 is at the end. That is the worst case scenario. So in that case, I have to make how many comparisons? If I have n elements here, how many comparisons I have to make? N comparisons I have to make. Before I can reach to a solution, whether the element is there or not, if I have n elements in my list, I have to make n comparisons. That is the worst case. So worst case is what we'll take. This is like too hard for us when we have a very large data set. So you can say your search depends on n. What is n? The number of items in your list. When your n grows, the search time, the runtime also will be more. So to avoid this, we have to find some other way, to reduce this search time, because when n is too huge, your search time will also be huge. So they went in for another kind of search called binary search. So binary search is very effective when you're going to have a large number of elements, and the only condition for binary search is the element should be in the sorted order. In linear search, we didn't have the elements in the sorted order. In binary search, before you start it, you should have that in the sorted order. So I'll tell you what binary search, how it works. This is the algorithm. I've taken it online from one of the portals. But we'll see how this algorithm works with a demonstration here. A simple algorithm. So let us take a list again with some values 11, 22, 33, 44, 55, 66, and 77. Now, how to use binary search here is we'll take the indexes for all these values. So what is index for 11? 0. Index for 22 is 1. So we take all the indexes. And then we have to take some variables here. This low variable will take the starting index, that is 0. The variable I will be mapped to the ending index, that is 6. So how this algorithm works is it will consider the starting index and ending index for the list. What are the starting index and ending index here? 0 and 6. Once when you find that, you should compute the midpoint. Midpoint is nothing but starting index plus ending index by 2. So what is the midpoint here? 0 plus 6 by 2. That is nothing but 3. So this 3 represents index 3. What is the element at index 3? You have 44. So you compute the midpoint and then you find that element in that midpoint. That is the first step. So even before going to this process, what you have to get is you have to get the search element from the user. What elements he wants to search for from this list. Say this guy wants to search for 66. I have given that here. Our first step is take the starting index, take the ending index, compute the midpoint. That is nothing but starting index plus ending index by 2. So you get 3. You go to the element in this midpoint, check whether 66 is equal to 44. Is 66 equal to 44? No. So now what we are going to do is, when we find that 66 is not equal to 44, we are going to do something. We are going to compare whether 66 is greater than 44. Whether this element is occurring after 44. Is 66 greater than 44? True. So 66 greater than 44 becomes true. So what happens here is, we are going to now assign our low and high points to be something else. We are going to just leave everything that is to this side. We are going to just drop half of the list. You understood that? Because 66 comes only in the remaining half. We first computed the midpoint. We check whether the element is equal to the midpoint. No. We check whether that search element is greater than the midpoint element. Yes. So the element should be somewhere over here. So we are going to drop off of the list. Now our low will be this index 4. I will be the previous index 6. So we are going to search only in this area. Again we have to compute midpoint here. What is midpoint here? 4 plus 6 by 2. This is the low, this is the high. So 4 plus 6 by 2 is 10 by 2. So we get 5. What is the element at index 5? 66. Is 66 equal to 66? Once when you compute the midpoint, you check whether the element at midpoint equal to such element. Is 66 equal to 66? Yes. So we found that the element occurs at in this list in how many comparisons now? How many comparisons? 3 or 2? First time we found the midpoint to be 44. We checked 66 is equal to 44. One comparison. It was not there, so we went in from 4 to 6. Again, we found the midpoint, the comparison between 66 and 66. So within two comparisons, we were able to find the element exists. Earlier, if you use linear search, how many comparisons you should have made? 1, 2, 3, 4, 5, 6 comparisons. Whereas here, it is 2 comparisons. The good thing about this is, say if I have 100 elements, in the very first comparison, I'll eliminate 50 elements. One of I'm going to eliminate. In the second comparison, another 25 elements I'll eliminate. So the speed of search will be very effective. So that's called binary search. You're going to use the indexes and search. The only thing is I did some I had some animations here. So that's what initially we should have these three things. What is the lower index, higher index for a search partition? Compute the midpoint, check whether the element is in the midpoint. If it is not there, check whether the element is greater than the midpoint element. Then you alter your lower and higher indexes. If the element is lesser than the midpoint element, then what you have to do? Your search will be somewhere over here in this range. Right. So searching for 66, we know how to do that now, right? We did all these comparisons and then we finally found 66 is at this location. Now I will give you another search for element 22. We'll carry out this exercise again. How many comparisons we are going to make? You're going to tell me. So you're going to tell me what we are going to do here. First we'll have this variable low, I. Say low will be 0, that is the starting index. I will be the ending index. Here it is 6. So I is 6. What is midpoint computation here? Midpoint is nothing but 0 plus 6 by 2, that is 3. So what is the midpoint index? 0, 1, 2, 3. 44 is at midpoint. Is 44 equal to 22? 44 is not equal to 22. First check is done. Is 22 greater than 44? Is search element greater than 44? Search element is not greater than 44. So you are going to drop all the elements here. We're not going to worry about all these elements. So our 22 should work somewhere over here. So 22 is lesser than 44, right? You know that. So your low will be 0. What should be your high? You should not go to 3. Your high should be midpoint minus 1. That is 2. So now your low will be 0. High will be midpoint minus 1. That is 2. So you're going to now compute the midpoint using 0 and 2. So what is midpoint for low and high to be 0 and 2? It's 0 plus 2 by 2. So you lead to 1. What is the element at index 1? 22. Is 22 equal to 22? Yes. Again in two comparisons you have reached the particular value. First important thing is if you have something like say 77, I will complete the code 55, 44, 66, 11, 22 and 33. The first thing you have to do is you have to sort it. Binary search will not work if you have not sorted it. That is also a disadvantage of binary search. You have to sort it. So how will you sort this? You just do L dot sort. I am using dot sort because the list should be altered. Now I'll have this found to be false. Again the same thing, I had this flag in the last experiment to learn linear searching. And then I have to assign low to be 0. Always index will start at 0. Low is 0. What is I? The ending index for a list. So ending index for a list I will be length of that list minus 1. Length of the list will give, if we have 7 elements, 7, but the index will be from 0 to 6. So it should be length of list minus 1. Now you know low and high, and you also know the element is not found initially. So we can put a while loop here. While low is lesser than equal to high. See, these two partitions, when you keep dividing, they will come and meet sometime. So low will be equal to I at the end. So that's what we are checking. When low has not met I, and found is also false, and found is equal to false. We have not found the element. What we are going to do here is we are going to compute midpoint first. Okay, when you use midpoint, you should also, I missed two things here. One is I should get the input search element from the user. Search is equal to int input, enter the search element. And then midpoint I should compute. So I'll have some midpoint to be 0 initially. Midpoint, some variable to be 0. So this is used for that midpoint computation. So midpoint equal to, it's nothing but low plus high by 2. Integer division. You should not go with float here. 2.5, there's no index 2.5. So go with integer division. And now you find this, right? You're now at the midpoint. How will you check whether the element at the midpoint? So we have to give list name, list of the index midpoint. We can even check this. If list of index midpoint equal to search element, then what we are going to do, okay, the midpoint element is search element. Then we'll stop our while loop. We'll say found is equal to true. When this condition found gets to true, our while loop will stop, because we have an AND in our while loop. Whether the partitions meet or whether you find the element, you are going to break our while loop. Okay, so if midpoint element is not equal to search element, say 44 is not equal to 66, then what we are going to do is we will go with an elif. We'll say whether midpoint element, that is 44, is greater than or is lesser than such. The first condition, right, is 44 less than 66. If 44 is less than 66, what we have to do? We have to assign our midpoint here. That is, low should be, the low value should be midpoint plus 1. Because you're going to search anything greater than 44 to the end of the list. I will be 6. Another elif, L of midpoint, the another condition is 22. If you have 22, 22 will be lesser than midpoint element, right? So we have to say L of midpoint, is this element greater than the search element? Say 44 is greater than 22. That's what we found, right? If it is greater than 22, then our high, we have to search from 0 to the I index. I index is nothing but midpoint minus 1. Because midpoint we have already compared. So from 0 to midpoint minus 1 index, we have to compare all the elements. That's it. So this will be continuously dividing it into partitions and searching. Only thing is, if found, we can also use a while loop here, but if found, we'll say print element is found. Else we'll say print, we'll say element not found. I'm having this issue. That's it. First you compute the midpoint, check if it is going to be the search element, that is this particular part. Next, what you're checking is the midpoint value lesser than the search value? 44 is less than 66. Then what will be your low value? Anything that is indexed greater than 44, right? So it's midpoint plus 1 to the end. So I'm assigning only low to be midpoint plus 1 because I will be the end. I is always 6 right there, right? I is 6. If the value is 22, then midpoint element will be greater than 22. That's the another scenario we have seen. So then we have to search from 0 to midpoint minus 1. So every time we come in, we check for the partitions and we run. Let me check whether this one works. It's a binary search algorithm. Let me check whether this one works for me. So enter the search element. Say if I search for 6, we'll search for 66. Element is found. We'll search for 22. We'll do our test cases. Element is found. We'll search for 99, which is not there. Element not found. But we are not able to visibly see. It's more quicker than linear search because both the data sets are very small, and it's our systems can really handle that very effective. But you have very large data sets like 100 million records, then you'll see the difference in the runtime for these two different algorithms.